All right. Hey, guess what? It's another time for seventh grade science live from South Beach. Beautiful sunny South Beach, Florida here. Hey, guess what? We're talking about some weather forecasting today. Nah, actually, I'm not in South Beach. Wish I was, but no. I'm still live from the Brenna Bunker here in the still quarantined Southeast United States. We're supposed to go to stage one today, which means lowering the restrictions a little bit. But hey, that doesn't mean you get to run out and party with your friends or anything else. You still have to maintain social distancing, 6 feet apart. Anyway, so today we're talking about weather forecasting. And unlike South Beach here with the beautiful, partly sunny skies and cool temperatures and beautiful water, it is a little bit overcast and actually really cold here in Carolinas, especially for the middle of May. And frankly, and I think my mom is supposed to get some snow today up in New York. And so, when's the last time it snowed in May for you, huh? Been a bit of time. So, anyway, so we're talking about weather forecasting, and I can explain why weather prediction is important. So, we've been discussing weather and how to assess its various qualities. We know the different variables that go into what makes up the current weather. We know that we can measure temperature, air pressure, wind speed, cloud cover, and other factors. But in reality, if we just wanted to know what was going on outside, why would we put all that effort into instruments and research? We could just open a window and stick our head out. That would tell us what's going on outside, right? That's the weather that's happening now. Weather is what's going on in the atmosphere right now. Well, we're really, like I said, if we want to know what's going on right now, we just open a window and look. That doesn't really help us, not help us much. It tells us we can go out and play, go, get that round of golf in, you know, or when you sit inside and stay on the Xbox. But either way, but that's just right now. But all the data acquisition, all the information we gather and everything else goes, what we're doing and putting it into computer models are to tell us what's going to happen. Well, it doesn't really tell us what's going to happen. It allows us to make predictions because unlike, you know, different things where, we actually know what's going to happen, like when Alabama, certain football teams play certain other football teams or certain basketball teams play other certain basketball teams, somebody's going to get whipped. Okay, yeah, that's almost a foregone conclusion, right? Well, unfortunately, it's not. Even some of the best teams fall, and some of the worst teams have a good day. As they say, blind squirrel finds a nut every once in a while. So, oh, with all those things and all the unpredictability, everything else, but especially with weather, because again, there is so much going on in the atmosphere that we literally still haven't figured out how to accurately quantify everything that's happening, on a day-to-day basis to the point where we can actually, regularly predict, accurately what's going to happen in the future. Now, so what we want, and the reason why we want to know about what's going to happen in the future is like, look, hey, I want to go to the beach or the mountains this weekend. What's the weather going to be like? Is it worth going? Do I need to cancel those reservations? Or do I need to keep them? You know, I'm having a cookout with all my family this weekend. Do I need to plan to be inside or outside? Or do I need to cancel the whole thing altogether because there's a hurricane coming? That's what we want to know from weather, about the weather. Not really what's going on now, because again, we can just open a window and look. We know what's going on now. We want to know what's going to happen later. And so we want to know, this drive to have that future knowledge leads us to pursue advancements in technology and data acquisition. There's an interesting word, data acquisition. Data is all, the temperature, the pressure as it happens now. Acquisition means to gather it in order to be able to more accurately predict future weather. This prediction of future weather is called forecasting. And the funny thing about forecasting, I always kind of laugh when I hear that word because I always imagine some voodoo witch doctor reading the bone when I hear the word forecast. Because, back in my day, that's about what it was. So anyway, forecasting is using known data, models, and previous experience and making a prediction about what's going to happen in the future. When I was your age, meteorologists, the scientists who study weather, meteorologists, actually, we need to know that. Slide myself over here. I'm stuck on the picture. Look. So meteorologists, wait, I have to highlight it first. Meteorologists are the scientists who study weather. Yep, you need to know that. So when I was your age, meteorologists, the scientists who study weather, were not nearly as accurate as they are today. They can usually tell you what's going to happen tomorrow with about 50, 60% accuracy. And they can tell you about the day after that, but 3 days out was a coin toss. Anything further in the future was just a guess on their part. We laughingly called them weather guessers. Now, through the advances in technology and computer models, we can fairly accurately predict weather about 5 to 7 days in the future. I mean, it's a long way in 30 years. Now, there are always mistakes and changes as they go, but for the most part, they get it right. Now, how did all of this change? Well, for one thing, they have more data as we have more weather stations all over the US. These stations report data more often to the weather prediction people. In times past, a person had to go out and physically read instruments. So in the old days, they had some airports had weather stations, and some major cities had weather. The top of one of the tall buildings, they would have a weather station, and so some person would literally have to go out to this box of stuff, and I mean, it was like a big cabinet outside, open the cabinet and read all the dials and gauges and everything else until. So what's the temperature? What's the air pressure? What's the humidity? What's the what's the wind speed? What direction is it? All of these things, how much rain's in the rain gauge. They had to go out and physically read these and do this, and then write it all down on a piece of paper, and then take it back inside, and then transmit it. In the old days, they literally had to pick up a telephone and call it in to a certain place, a certain thing. They couldn't. There was no fax. There was no internet. They literally, well, actually, in the real old days, they had to use a teletype, a telegram, the wireless, they would send, hey, the weather is bad here, and to us. And that's, I mean, you literally, truly, previous to the 30s and 40s, if you wanted to know what the weather was, you would send you go down to the telegraph office and you would telegraph to a town somewhere to the west of you by a day or so's travel and go, hey, what's the weather there? And with the general idea that what the weather they had there was coming to where you were the next day. So that was the best you could do for weather prediction. Telegraph somebody and go, hey, what's going on there? And then knowing that something like that would happen here the next day. But nowadays we have it's changed. There's not a person walking out to some box reading all these instruments. There are sets of automated instruments all over the United States that automatically report, and they report much more often than a person having to walk out to a box and turn around and walk back in and make this report. So whereas that report, from the dude walking out the box might happen once or twice, 3 times, 4 times a day while he was on shift. I mean, again, we got to remember, this is a person doing a job that's usually some other job, and they just happen to have to do this too. So we just squeeze this in here and there. So you might get 2 or 3, 4 reports out of a person, or if they had 2 shifts, you might get 5, out of 2 people. But again, overnight, no, nobody's taking in. There's nobody's reading the data overnight. So I mean, you had this entire section of time where nothing was happening, and so the data was sparse and it was very incomplete. But nowadays we have these automated stations that record all this stuff automatically and are hooked up to the net and report it automatically to these huge computer data banks, which plug that data into their what they're using to build their models out of. So so the ability to gather all this data is what makes us a lot more accurate in our predictions. And so data point, so here we have now, they report conditions by the minute to huge networks of computers that take the data and apply it to continuously running modeling programs. These computer programs are built by meteorologists to accumulate all the data they can, apply knowledge of previous weather events and actions, and forecast future weather as probabilities. So again, so these these computers take in not only the data, so what's happening now. So they have all this data from years and years and years of collecting data of what's happening now, and so they can track. All right, so when this happens, when this happens, when this happens, 2 days later, this happened. So they have all that information in there, and they are able to take that, and scientists build what they call models. one of the the interesting, more interesting way of looking at models is this. So spaghetti plots. This guy runs a website and he looks at all the different things that happen with hurricanes. So again, we're not really in hurricane season right now, so there's not a whole lot going on. And we'll come back here tomorrow to look at some of these weather things. Let's see. Previous. Back up. We're gonna look here tomorrow. So we look at something like this, and these are the typical spaghetti plots. So and what happens with weather programs is you get these predictions. There's one. So looks like patience. So the models. All right, this is one of those days where it's just like hurricane. Let's just pick one. All right, so you see all these lines? Every one of these lines on this, and that one's a joke. Over here, here's another one. This is, literally it says forecast models. And each one of these, I mean, it's got a name. It says NAMI, CMC, AEMI. All these things are different models. And so the computer, so a meteorologist builds a model and he thinks based on his experience and his knowledge and what he has studied that these are the things that are important to drive this model. These are the things that this person thinks and that person thinks that that drives the model. And so what you end up getting is what they call spaghetti plots, which are all the different models. And so everybody just kind of runs them all and says, all right, so here's what all the models say. And what you end up doing is what happens is right down here, real close to it, all the models are kind of sitting in the same spot because they're really sure over the next 12 hours, here's what's going to happen. But then as you get further and further out, the models get further and further away. Well, in this case, they're not. In this case, they are. Look, by the time we get, right through here, yep, it's all pretty close. Then they start getting some variation here. And by the time we get out here, it's like, wow, this one's up here, this one's way down here. That is very, that's how different the different models get. So again, models are predictions, and the models are computer programs that take certain data and give them weights. This is more important than this. This is more important than this. This is more important than this. So the computer takes all those things, weights it, based on the person who built the model, and then gives you a prediction based on here's what's going to happen with this given weight. So everybody goes, all right, let's look at all the models, and then usually where especially when you have one like this where so many of them are tracking right there, yeah, that's actually kind of a lot of space, but it gives you a really good picture of what everybody except for a couple people think this thing's going to do. So these models typically spit out information, and again each weather forecaster has his own favorite couple of models, and usually they'll kind of complement each other. And so this is where all this data and all these things allow us to make a lot more accurate predictions about what's going to happen in the future as far as weather goes. And so when you hear a person forecasting weather, they talk of chances of something happening. There is a chance, or there is a good chance. They couch their predictions in phrases like these because that's what their modeling computer program is telling them. This is there is this blank percent chance of this result. There is a blank percent chance of this other result. They take those computer predictions and what they know about weather and from their studies and experience, come up with a forecast that they give out to the public. How they give it out depends on the medium that they're operating in. So the guy on the radio reads it to you over the radio. So I mean he has to use words and stuff that kind of generate pictures and allow you to understand what he's saying just hearing his voice. People on TV, they use other things, and then you have our friendly neighborhood phone apps, which give us all kinds of information. which is what most of us are used to looking at the weather. So if you're interested in the weather, you punch your weather app on your phone, or you go to your favorite weather website, and this is what you get. So you get symbols, and you get lines, and you get graphs. So this is literally, the weather, Apple weather. That's not Apple weather. This is you punch in weather in the Chrome, and this is the first thing that pops up is the weather for your area. So Friday, cloudy and rainy. Saturday, sun, sun, sun. Some clouds, some clouds, some clouds, some clouds. So again, pretty vague, isn't it? I mean, especially for a 12 or 14-hour day, and the temperatures, the high and the low, the high and the low. I mean, geez, it's gonna get cold Saturday morning. That's how it goes. So the symbols, across the bottom indicate cloud cover and likely conditions, and most of our devices have a weather app that reads somewhere in there. Then you go down here. This is my favorites. It's Weather Underground. So this is the 10-day forecast from Weather Underground. It's a graph, which is a lot of information in a very readable way. Now, it is still a prediction based on computer modeling. And if you come back to this every 6 or 8 hours, it actually changes on a regular basis. So for the first couple of days here, 1, 2, 3, 4, 5 days out, right about here, this doesn't, it changes some, but it doesn't change much. But once you get past about 5 days, 6, 7, 8, 9, and 10, these days change pretty quickly, and sometimes entirely. So this rain will move, it'll get here sooner, or it won't, it'll suddenly be pushed back and get here later. But you look at this graph, the first part of the graph right here, it's got, so the lighter portion here is the day, and then there's the night, and the day and the night. You can see the temperature up in the day and down during the night, and up during the day and down during the night. But you can see it's slowly climbing up to the point where the temperatures go up. And then you have your green, which is your dew point. So obviously the dew point is higher when there's more moisture in the air and lower when there's less moisture in the air. So the dew point drops off down here at almost, nil. So guess what? If there's no moisture in the air, you're not likely to get rain, are you? But as the dew point starts wandering back up, so we start running the clouds, and dew point keeps coming up. And when the dew point touches, gets up there, as high as this is right here, yeah, guess what? Guess what? Chances of showers go up. We get down here to, this one's got a bunch of different stuff on it. It's got the line right here is the barometric pressure. The green line is the humidity. The blue, right through there, and right here is the chance of precipitation, and the gray is the cloud cover. Look at that, cloud cover, 100%. And then this line right here, you can actually move. It actually gives you the time. So you can move the line and go, all right, dude, I got a soccer game at 6 o'clock on this whatever day. You can move that line and find 6 o'clock on that day and give it, here's your prediction. So you're like, okay, so it actually, gets down to the point where hour by hour. Now, again, in these first couple of days, pretty accurate. Out here, not so much. Again, it is a prediction. It is, effectively, it's voodoo, but it's voodoo with science backed up to it, not just chicken bones in a bag. So that's weather prediction. I mean, there's a reason for it. There is, because we want to know what's going to happen in the future. If you're a farmer, you want to know if it's going to rain. If you have a beach house, you want to know if there's a hurricane coming. If there's a parade this weekend, you want to know if you want to take the kids down and plan on that, or man, it's going to rain. They're going to the parade's going to be miserable. We ain't going down and being outside. I don't care what the parade is. So those are the kind of things that we need to know future information about, and that's why we talk about weather forecasting. And again, it is models and predictions and guesses based on data and based on prior, happenings. So that's why it is never 100%. And like I said, right in here, they can get this part first 3 days. That's almost written in stone. 4 and 5, pretty good chance it could be like that. Beyond 5, like I said, it's a model. It's what we think is going to happen, but it'll change. I guarantee it. So, but it changes continuously, and you have to keep paying attention. So again, now tomorrow, we're going to take this information, in these models and these things, and we're going to put them on weather on a map. So we're going to take a look at what a map looks like for current. Here's what's happening now, and then here's how to read it. what all the map symbols mean, and then we'll go from there to map predictions. So hope everybody has a great day, rest of the day today for 7th grade. You may have some questions today, you may not. Just check. So we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 7 lessons effectively left in this unit. So basically another week and a half worth of lessons, and then we'll have our unit assessment on this unit 7.E.1. So kind of keep that in the back of your mind. Remember to like the video. Remember to register for the channel. And hey, remember, attendance is taken by saying hi in the comment section. So throw your comment down there. Hey, I was here for attendance. Appreciate it. Thanks for everybody coming out. Stay safe. 6 feet away from each other, people. 6 feet. And we'll catch you guys next time.